Lesson 4.2, going to be talking about trigonometric functions of acute angles. When we're talking about trig functions, we're usually going to be talking about right triangles, so we're going to be dealing with acute angles. If we have a right triangle, we're talking about an angle. We're going to have an adjacent side, an opposite side, and the hypotenuse, or according to the picture, the hypotenuse, if that's how you say that. Okay, so we're going to be using right triangles, finding all 6 trig functions. Okay, previously we talked about sine, cosine, and tangent. We're going to talk about 3 more that we haven't talked about as often. So the acronym we're going to use to help us remember how to find those basic trig functions is SOHCAHTOA, or as some of you like to call it, Sacagawea. Whichever one you prefer, go with it. So SOHCAHTOA, SOH, sine, is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. Tangent is equal to opposite over adjacent. Okay. So we're going to use these 3 basic ones. Sine of some angle is equal to the opposite over the hypotenuse. Cosine of an angle is equal to the adjacent side over the hypotenuse. And the tangent is equal to opposite over the adjacent. Okay, so these are the 3 basic ones that we've talked about in the past. But now we're going to learn 3 new ones. Sine corresponds to cosecant, which we write shorthand as CSC. So the cosecant of an angle is equal to the hypotenuse over the opposite side. So the cosecant corresponds to sine because they are reciprocals of each other. So if we know what the sine of an angle is, we can quickly identify what the cosecant is. Next one we're going to talk about, and it corresponds to the cosine of an angle, is secant, which we write shorthand as SEC. So the secant of an angle is equal to the hypotenuse over the adjacent side. And then the last one, corresponding to tangent, is cotangent, which we write shorthand as COT. So the cotangent of an angle is equal to the adjacent side over the opposite side. So one thing you might notice, or you might be wondering, why does cosecant correspond to sine and not cosine? Okay. I really do not understand why they don't have cosecant correspond to cosine and secant correspond to sine. It would make more sense that way. Okay. So you're going to have to remember, cosecant corresponds to sine and secant corresponds to cosine. You're going to have to find some way to remember that, because that's one common mistake. You're going to try to relate cosecant to cosine, and they are not related. Okay, so find a way to remember and not get those confused. In your book, they talk about 2 famous triangles. Okay, one's a 45-45-90 triangle. The other is a 30-60-90 triangle. I've talked about those in the past. They're famous or special because of the values of the side lengths. They're pretty common. I'm not going to require you to memorize those 2 triangles. I think it's more useful to be able to apply and find the lengths of any triangles. But it might help you to quickly just take a glance at page 330, where it talks about those 2 famous triangles in example 1 and example 2. Just take a quick glance at those. That way you have a little bit of a background when talking about those 2 triangles. What we're going to focus on is finding trig ratios for any triangle depending on some information we're given. Okay, so the only thing we're given in this first problem is that the sine of theta is equal to 5 over 6. Okay, theta is referring to some acute angle, and we know the sine of that acute angle is 5 over 6. So the most useful thing to do to start these types of problems, because we know one of them, we have to find the other 5, because we know there's 6 total, is to construct a right triangle. Okay. It does not matter how you construct your right triangle. You could have drawn it like this. You could have drawn something like this. It does not matter how you draw your right triangle. I normally draw them like I have down below because that's what I've done throughout my whole math career when talking about trig functions. This is just the way that helps me quickly find these values. That's what I'm comfortable with. Whatever type of right triangle you construct is going to be okay though. Okay? These normally aren't going to be drawn to scale. Okay? But that's okay. It's just using some triangle to give us a rough idea and help us get through the problem. So, we have this right triangle. We know one of our angles we're referring to as theta. Okay, so you can name that angle. You could have made theta the other acute angle and up top. I'm just more comfortable using theta down at the bottom. Okay, that's what I'm used to. So if we know sine is 5 over 6. Okay, remember, SOHCAHTOA, sine is opposite over hypotenuse. So the opposite of theta would be that side. So the opposite side is the length of 5. The hypotenuse is 6. The hypotenuse is always opposite of the right angle. So now that is the length of 6. So we need to find that missing side length. Okay. Now we're going to use something you've used a lot, the Pythagorean theorem. A squared plus b squared equals c squared. Okay. We know what b and c are. We're trying to find that missing side length. So we can go x squared plus 5 squared is equal to 6 squared. X squared plus 25 is equal to 36. Subtract 25, x squared equals 11. Take the square root, x is equal to radical 11. Okay. Remember, technically, if we took the square root of x squared, we would get plus or minus radical 11. Okay. Since we're talking about a length of a triangle in this case, in standard position, it's going to be a positive value. So our x value down below is radical 11. Okay. So now we have enough information that we can find all 6 trig functions. We know the sine of theta was 5 over 6. Cosine is adjacent over the hypotenuse, so the adjacent side to our theta angle is radical 11 over 6, and tangent of theta is opposite over adjacent, which would be 5 over radical 11. Now, if we're trying to find the other 3, remember those are just reciprocals of the other ones. So sine corresponds to cosecant of theta would be the reciprocal of 5/6 is 6/5. The secant of theta would be the reciprocal of that, 6 over radical 11. Oh, that is not a good radical 11. 6 over radical 11. And the cotangent of theta would be radical 11 over 5. So if we have one trig ratio that we're given, we can construct a right triangle to give us an idea of what we're looking at, find the missing side length, and then using SOHCAHTOA and our reciprocal properties, we can find all 6. One thing I'm going to talk about quick, when you're checking answers in the back of the book. Let's just say we look at secant of theta equal to 6 over radical 11. Some of you might remember there's one issue we have with this ratio. We have a radical in the denominator. It's not standard to leave a radical in the denominator. So we would have to rationalize that, meaning we have to multiply that by something to get that radical out of the denominator. We rationalize it by multiplying this value by radical 11 over radical 11. So secant of theta would be 6 times radical 11 over 11. Radical 11 times radical 11, those two radicals combine to just give us an exponent of 1, so it's just 11. I'm not going to be as concerned about you simplifying radicals in the denominator. Okay, I think that's a fine answer. If you're talking about an ACT or some standardized test, if you get your answer and it's not one in the book or one of your options, this would be something you would probably have to do. You might have to rationalize the denominator to rewrite it in a different form. Okay. Also, if you're checking answers in the back of your book, they're probably going to have it in this rationalized form. Okay, so just make sure you're aware of that and understanding those values are equal. The one that we just went through and did, 6 radical 11 over 11, that's more of a standardized way of writing it. Okay? The next thing we're going to briefly talk about are some common calculator errors you fools are going to make. They talk about these on page 332 in your books. There's basically 4 ones they refer to. Okay. The first one is simply making sure that you are in the correct mode. Okay. So if we have, or if you want to check which mode you're in, you simply click mode, and that tells you, if you go down to the third one, right now we're in radians. If you're talking about degrees, you would have to go over here, push enter, and change it so that you're in degree mode. Okay? Just checking to make sure that you're actually in the right mode. Okay? That's the first common mistake. The second mistake is when trying to use your calculators to find an approximation for cosecant, secant, and cotangent. Okay? So if we're trying to find, let's just say, the cotangent of, well, if this would write the cotangent of pi over 4. Your calculators do not have a button that you can click for cotangent, cosecant, or secant. Okay? That's why you have to use those reciprocal properties. Cotangent is related to tangent. It's the reciprocal of that value. So if we're typing in, we can use our calculators and type in the tangent of pi over 4. If we're looking for the cotangent of that value, we simply have to take the reciprocal, which is raising that whole thing to the negative 1 power. Think of exponent properties. If we have a negative exponent, we write it as 1 over that value. We're taking the reciprocal of that value. So this is what we have to use if we're trying to find the cotangent of pi over 4 using our calculators. We have to type in that reciprocal property using negative 1 exponent. So the cotangent of pi over 4, you can see in the top part where I type that in, is equal to 1. The mistake some of you will make is, if you look on your calculators, right above the tangent button, which is right above the 9, a couple spaces, if you push second tangent, it has an inverse tangent. Tangent raised to the negative 1. That is called the inverse tangent function. That's something we'll get to later in this chapter, and is completely different than that whole thing raised to the negative 1 power. The inverse tangent, tangent of pi over 4 raised to the negative 1 power, which is cotangent, two completely different values, which you can see by the calculator. The cotangent of pi over 4 is equal to 1. The inverse tangent of pi over 4 is 0.6657, so on. Okay, so just making sure you're typing those in your calculators correctly. And also, that basically covers two common errors of one, just making sure you're typing that in correctly. The last thing is making sure to close off your parentheses. If you type in the sign of, let's just say, pi over 2 plus 2. Okay, let's just say we want to find out what this value is. So we have the sign of pi over 2 plus 2. If you go to your calculators and we type in the sign, notice it automatically puts a parenthesis in there. Okay, so when we type in pi divided by 2, we need to make sure we close off that parenthesis before adding 2 at the end. Okay, we get that value. Notice we get a value of 3. If I type in the sign of pi divided by 2 plus 2, notice we get some decimal that is completely different. Even if I would type in the sign of pi divided by 2 plus 2 and close off the parenthesis, we're going to get that same value. So notice, when you type in a trig function, your calculator just automatically put a parenthesis. So if you don't close that parenthesis off, it's just going to take that to the end and automatically put that parenthesis at the end. Okay? So you need to make sure that you close that set of parentheses if you're adding something to the end. So those are the basic mistakes that you would potentially make on your calculators. So make sure you don't do those. The last main idea that we're going to be talking about in this lesson is solving a right triangle. Solving a right triangle means we're finding all 6 parts, which means all 3 angles and all 3 side lengths. So in this example, we have a right triangle. The hypotenuse is 8. We don't know what either of the 2 legs are. We know one of the angles, one of the acute angles is 37 degrees. If we know what one of the acute angles are, we can quickly identify what the other one is. We know a triangle adds up to 180 degrees. All 3 angles add up to 180 degrees. If there's a right angle that's 90 degrees, which means the 2 acute angles are complementary, meaning they add 90 degrees. So 90 minus 37 is equal to 53 degrees. So right away, we can identify that missing angle is 53 degrees. So you've already found all 3 angles. Now we just have to find the lengths for A and B. Now we're going to use some actual trigonometry, those trig ratios we talked about. First, let's say we're trying to find A. Okay? So if we're looking for side A, and I'm going to use the 37 degree angle. So if I'm talking about that 37 degree angle, A is opposite of that, and I know what the hypotenuse is. So opposite and hypotenuse, I need to use sine. Think of SOHCAHTOA. So the equation I'm going to write is the sine of 37 degrees is equal to A over 8. Okay. So using trigonometry, SOHCAHTOA, thinking about which equation, which function I can use to create an equation that we can solve. So now if we're trying to find the value of A, all we have to do is multiply 8 by both sides of this equation. So you get a value, A is approximately, now we're going to use our calculators and go and type this value in. So if I type 8 times the sine of 37, I get negative 5.148. We can just round that to 2 decimal places. I hope some of you are thinking about, if this is the length of a triangle, side lengths of a triangle, we shouldn't have a negative length. Okay? So there's a problem here. So I was a fool, and I did not check my mode before we typed this in. We're talking about degrees. If I look at the mode I'm in radians. So we need to change that to degrees. Second, quit. If I type this in now, 8 times the sine of 37 degrees, now I get an answer that makes sense. 4.81. So A is approximately 4.81. We're talking about inches, centimeters, meters, whatever we're talking about. Okay. So now we only have one thing left we need to find. The value of B. Okay. So, a couple different things we could do. We can use 37 degree angle. Okay. I could set up, if we're going to use the 37 degree angle, B is the adjacent side, and we still know what the hypotenuse is, 8. So we're going to use the cosine of 37 degrees is equal to B over 8. Okay. One thing I would not recommend doing is, we found the value of A, which is 4.81. That was an approximation. Okay, we had to round that decimal off. So when you're trying to create an equation that you could use, we technically could have set up the tangent, or which one? Tangent of 37 degrees is equal to 4.81 over B. We could have gone opposite over adjacent. It is not best to use that because 4.81 is a rounded answer. 8 is an exact answer, so it is preferable to use the cosine of 37 degrees using that equation. Okay, so that's the equation we're going to use. Okay, that's something you need to think about when you're solving right triangle. Which one was given as an exact answer, and which one is something I found and had to round. We want to use the exact answer. So again, in this case, we're going to multiply both sides by 8. Multiply both sides by 8. If we type this in on the calculators, now we're in degree mode, so we're good to go. 8 times the cosine of 37 degrees, and we get 6.39. So B is approximately 6.39, whatever unit we would be talking about. We also could have set up a different equation to solve this. Okay, and I'm going to show you that it does not matter which one you use. There's multiple ways we can set these up, so it just depends on which one you're comfortable using. So now I'm going to use that 53 degree angle, and I'm going to try to find the length of side B. So if I'm talking about that 53 degree angle and using that as my reference point, B is the opposite side, and 8 is still the hypotenuse. So you have the opposite and the hypotenuse. So the sine of 53 degrees is equal to B over 8. So now if we would multiply this by 8, multiply by 8, and now type that in on the calculator, 8 times the sine of 53 degrees, notice you get the exact same answer, 6.39 if we round that. So, does not matter if you use this trig ratio or this trig ratio to set up your equation, you're going to get the exact same answer. Okay, so there's many different ways you're going to be able to solve these problems, so you can be a little creative on which one's easier for you to work with. The last example is an application problem where we can find the height of some fancy building. Okay, so we have some information we know. At a point 150 feet from the base of the building, the central angle, or the angle of inclination, to the top of the building is 70 degrees. knowing that that's 150 feet away, angle of inclination is 70 degrees, we can find the height of the building. Okay? Because we have the opposite and the adjacent. So if we have the opposite and the adjacent, we need to use tangent. So the tangent of 70 degrees is equal to h over 150. And now, just like the last problems, all we need to do is multiply both sides by 150. And then if we use our calculator, make sure we're in degree mode still. 150 times the tangent of 70 degrees. Close off that parenthesis, and we get 412.12. We could probably just round that to h is approximately 412 feet. Using these trig ratios, if we have enough information, we can find the height of the building and things like that. Okay. That concludes lesson 4.2. You can go ahead and get started on the homework.